Okay, so in this next video, we are going to be talking still about exponential growth and decay, but specifically we're going to do an example on decay. So if you didn't watch my growth video, you might want to go back and watch that before watching this one. So we're going to go through a problem. It's going to set up a decaying situation, right? Which means something is decreasing instead of exponential growth, where something starts out slow and then quickly gets faster and faster. It's kind of like we talked about a zombie apocalypse in the last video. So now we're going to talk about when something decreases. So here's our situation. We have this person named Helmut from Finland. He is heading towards the windmill in a very peculiar way. What he's doing is he's starting 160 feet from the windmill. So this original distance is 160 feet. And on his first trip, he walks half the distance to the windmill. So he walks and stops here. So that would be 80 feet, right? Half the distance. And then he's here. And again, on his next trip, he walks half of what's left. So again, since there's 80 feet left, he's going to walk 40 more feet because that's half of 80. Okay, and then he's just going to keep following that pattern. He's just going to keep going half of what's left until, well, I guess we'll see. So we're going to model the distance, which is represented by the letter D, that Helmut has remaining to the windmill after n trips, right? So when n is 0, he's 160 feet away. When n is 1, that means he's taken one trip, so he's at 80 feet. And then at n equals 2, that's 2 trips. So we talked about this. After 2 trips, we half that again, right? So we're doing half each time, 1/2. So what's half of 80? That would be 40. And then half of that again would be 20. And then half of that again would be 10. So you might be thinking of this as dividing by 2, right? Which is correct. We are dividing by 2 each time. But when we're talking about developing a pattern here, it is much more convenient for us to talk about multiplying. So instead of dividing by 2, we can think of that as multiplying by 1/2. Those are really the same thing. Look, 80 divided by 2 is the same thing as 80 times 1/2. Either way, we get 40. So we're going to think of this as multiply by 1/2 each time. So let's continue this pattern. We want to find a pattern, kind of like we did in our growth video. Okay, we want to find a pattern in order to develop a formula that can predict future outcomes. Okay, so we talked about how at 0 trips, he started 160 feet away. And then on the first trip, we did 160 times 1/2, which got us 80. And then on our second trip, we took that first trip's distance and we times it by 1/2 again, right? And we ended up with 40. So notice that we are at timesing 1/2 twice at this point, right? And then again, on our third trip, we started with 160 and we timesed 1/2 3 times to get our answer of 20, right? So I'm going back here. I'm going back to this table. This is what we're doing. We are times 1/2 once, times 1/2 twice, times 1/2 3 times. The amount of times that we're halving that distance is corresponding to the number of trips that we're taking. So we can develop a pattern. If we had 4 trips, how many times 1/2s are we going to have? We're going to have 4 of them. So it's going to be 160 times 1/2, 4 times. There is a nicer way of writing this, and it is using exponents, right? 160 times 1/2 to the 4th power. That got us 10. We can double check that our formula is working in our calculator. Times 1/2 raised to the 4th. That is 10. So we're on the right track here. So let's write a general formula. So the distance from the windmill is equal to 160 times 1/2 raised to the n power. N represents the number of trips we have taken, right? Because on the fourth trip, we raised it to the fourth power. On the third trip, we had 3 of these. On the second trip, we had 2 of these. On the first trip, we had 1 of these. And on the original situation where there was 0 trips so far, we didn't have any 1/2s yet because we didn't start yet. Okay, so this is our formula. This is an exponential decay formula. This is different from the last video because the number in here is a fraction. That's what makes it decay. So how far is he from the windmill after just 6 trips? Provide a calculation that justifies your answer, and don't forget those units. So our distance at 6 trips is going to be equal to, well, we're just going to plug in 6 for n because that's what n represents, is the number of trips. So let's grab our calculator. 160 times 1/2 to the 6th power, and that is 2.5 feet from the windmill. Okay? So there is another page to this problem. I want you to try the second page on your own, and we, of course, will go over it in class together.